Yesterday we started a new unit on uniform circular motion. And of course, what we mean by uniform circular motion, motion of an object as it goes around a circle, but specifically the word uniform would mean constant speed, right? It's not speeding up or slowing down. So it's going around in a circle, but it's not speeding up, it's not slowing down. We defined two brand new terms associated with uniform circular motion, and then we just kind of adjusted one term that we had already learned about from day 2 of Physics 20. Our first term is frequency. Do you guys remember what frequency means? Yeah, it's the number of revolutions. Well, we say the number of revolutions per unit time, right, as opposed to per second necessarily. But in the end, what's the unit of time that we almost always use? Seconds. So really it is the number of revolutions per second. There are times when we use a frequency that's not in revolutions per second though, right? RPMs, revolutions per minute. If you look at the tachometer of your car, right beside the speedometer, most cars have a tachometer and it measures the frequency of the engine. Okay? You can see the needle going up, 1,000, 2,000, 3,000 RPMs, revolutions per minute. It's not actually revolutions. It's the number of times the pistons in the engines are going up and down. That's what we call actually simple harmonic motion, a repetitive motion that's going up and down like this. But it still has that term frequency associated with it, and we measure the frequency in RPMs as opposed to in revolutions per second because of the number that it is, right? It makes more sense to talk about that frequency in revolutions per minute than it does to talk about it in revolutions per second. All right. So it is the number of revolutions per unit time. Usually we use seconds, but sometimes we can use minutes as well. The symbol is a lowercase f as opposed to a capital F, which means force. Okay, we want to make sure we distinguish because there are going to be problems later on in this unit where we have both frequency and force in the same problem. And if you start mixing up the symbols for them, then you're going to start mixing up the variables and mess up the question. So let's make sure you remember to make it a lowercase f. The equation for frequency would be number of what, sorry? Yeah, number of revolutions divided by the time. And again, the time is usually going to be measured in seconds. So we're going to say the frequency is measured in revolutions per second. Or we could say RPS. Sometimes we do that with frequency. What's the other set of units that we use that means the same thing as a revolution per second? Hertz, good. So 1 revolution per second is equal to 1 hertz. Yep. Good question there, just asked by Cameron. If we get a question where we're given revolutions per minute as our frequency, or even revolutions per day, or what's the frequency of the Earth orbiting on its rotating on its axis? 1 revolution per day, 1 rotation per day, right? Or you could say 1 rotation per 24 hours, right? Those are valid units, just like kilometers per hour is a valid unit for speed, right? Do we use kilometers per hour when we're doing calculations? Not usually, right? Almost never. So if we always convert to meters per second from a valid unit of kilometers per hour, then we're gonna convert to revolutions per second from a valid unit of RPMs. Okay, even though it's valid, we're not going to use it. Period is the exact opposite of frequency. If frequency is the number of revolutions per unit time, then the period would be it's the time per revolution. How much time it takes for 1 complete revolution. The symbol is a capital T as opposed to a lowercase t. Be careful with that one as well. Lowercase t represents time, any time, including the time for 1 revolution. But we want to be specific here. Okay, the symbol that we're going to use specifically for the period is capital T. That's always the time for 1 complete revolution. The equation would be time over the number of revolutions. It's the exact inverse of the frequency equation. The units would be, well, sometimes we say seconds per revolution, but usually we just call it seconds. So the period would be measured in seconds, usually, almost always. Yep. For this, sorry, could you repeat that? Yeah. It depends on the context. Would that time be super small or big or whatever? If you're talking about um, if you're talking about how long it takes a DVD to spin around 3 times, then that time would be very small. Okay, but if you're talking about the time that it takes the Earth to go around the Sun 4 times, well, then that would be really big. It would be 4 years, right? So sometimes it's going to be a small number, sometimes it's going to be a big number. It completely depends upon the context. Okay, just like most other variables, like speed, for instance. If you're talking about the speed of a snail, it's really small. If you're talking about the speed of a meteor, it's going to be very big, right? All right. What's the other equation that relates the period to the frequency? T equals 1 over f. They're the exact inverse of one another, right? So if frequency is revolutions per time, period is time per revolution, then the period will be equal to the inverse of the frequency. And similarly, we could use f is equal to 1 over t, the rearranged form of t is equal to 1 over f as well. Units stay the same. Speed. Here's the other one that we learned yesterday. The speed of an object in uniform circular motion is always constant. The velocity isn't, right? The velocity is changing because the direction is changing, but the speed is always constant. And if the speed is constant, we're going to describe that speed using d over t. All right. What's the distance around the circle called? Dryden, what's the distance around the circle called? You remember that? Good. Circumference. And what's the equation for circumference? There's 2 equations that we could use. They both mean the same thing. Kayla, what's the equation that we use for circumference? Anybody else? Yeah. 2 pi r, we could use pi times d, pi times the diameter. I just like to use 2 pi r for whatever reason. And that's what I've put on your data sheet. So that's what we'll continue to use in class. What's the time around the circle once? Ashton? Yeah, the time for 1 full rotation, which is? The time for 1 revolution is defined as? Period, right? The time for 1 revolution is the period. So we're going to say that v is equal to, in the context of uniform circular motion, the speed of an object going around a circle is 2 pi r over t. Good? What are the units for that? What are the units for speed? Of course it's meters per second. We're not going to change anything there, right? 2 pi r over t gives us meters per second. We did a question yesterday, one example yesterday, where we had to find the frequency in hertz and in RPMs of this magnetic platter on a computer hard drive spinning around. And I think we found that the frequency in hertz was 120 hertz. And we converted that to RPMs. Do we expect to see a smaller number for RPMs or a bigger number for RPMs? You got 120 revolutions in 1 second, which you think about that, that's pretty fast, right? 120 revolutions in 1 second. Should we expect to get a bigger number or a smaller number for the number of revolutions in a minute? We should expect a number that's quite a bit bigger, right? Because you got 59 extra seconds to get more revolutions, right? So we're going to multiply that by 60 as opposed to divide. When you do that, we ended up getting 7,200 or 7.20 times 10 to the 3 RPMs. Okay, we did this question yesterday, so I'm not going through it in detail again today. I just wanted to go through that conversion because that's one that people mess up on, right? Minutes, seconds, do I multiply, do I divide? We know it's 60. Is it multiply or divide? Okay. Even if you guess wrong, that's okay. 120 divided by 60 is 2. Does it make sense? No. You can't get 2 revolutions in a minute if you got 120 of them in a second. So just ask yourself if it makes sense and then move forward. All right. I got 3 questions for you to work on. This is your task today, and I'll ask you to finish those up for Monday, please, if you don't finish them today.